All right, so just a quick video here to talk about these reading guides that you're doing online because we have virtual days randomly. First of all, thank y'all for actually looking at them and doing them. So I'm going to scroll down here. This is 5.2 and this is 5.2, so I'm in the right section. And as you no doubt already have noticed, like here it says wave nature of the electron, and here it says wave nature of the electron. So I will find those answers in the text. For example, it says, what was Bohr able to show? So then we read the thing. It says Bohr's model of atom was valuable for demonstrating how electrons are capable of absorbing and releasing energy and how atomic emission spectra were created. So this is what Bohr was able to show. Okay, so that's what I'm going to do. And so I might come over here and type in how electrons absorb and release energy and how atomic emission spectra are created. Right, and I'm just going to delete that to a more reasonable size. All right, so then there's my answer. Now, if you write the answers in your notebook, that's fine. If you write the answers in the doc, that's fine. Ultimately, we want to have this in your notebook. So if you do it online and then you print it and put it in your notebook, that's fine. If you rewrite it later into your notebook, that's fine. But ultimately, we want this to be your notes that you're going to use to study with. Now, another question that came up was about the word problems. So I'm going to make this a little bit bigger if I can. All right. And then now this says sample problem 5.4. So I'm going to scroll down to sample problem 5.4. That's where I'm going to find the answers. All right. And it has the known stuff, the mass of the electron, Planck's constant, velocity. It's all right there. And then we have the unknown, the wavelength. And here I have wavelength equals question mark. Okay. Then they give us the formula. I have the formula. All right. The formula equals Planck's constant divided by the mass of electron times the speed of light. And oh look, that's what I have there. Then I substituted in the, instead of having J for joules, I put in kilogram meter squared over second squared, because that's what a joule is equal to. And I have kilograms and meters and seconds down here, so I need kilograms and meters and seconds on top. And then I expressed that so that you can see how things would cancel out. So you've got second squared here. You have seconds times seconds here. That's second squared, so they cancel out. You've got meter squared here, and you got meter here. So this meter will cancel out down here, and then one of these meters will cancel out, leaving just meters. Kilogram here and kilogram here will cancel out. Okay. And then, now they don't have that exactly the same here because they still have joules. They're expecting you to just know that a joule is 1 kilogram meter squared divided by second squared. I wanted to spell that out for you though, so I put in kind of an extra step there. And then I see that the answer is 2.42 times 10. There's two ways you can do this. You could put the little arrow thing called a caret, which isn't showing up for some reason. Maybe it's because I'm using italics. Oh, it's because I'm in the equation. All right. Like I inserted an equation so my text could be fancy. So what you could do, if you can't type in there, you could just click to the end of it. I'm going to turn off italics. And you can say 2.42 times 10. And again, you can either do a little caret thing and then do negative 12 meters. Okay. Another thing you could do with Google Docs, now I'm not sure if it works in Word, In Word, you have to go up to the settings and click superscript or subscript. In Google Docs, if you press Control and period, that will make a superscript for you. And then if you press Control and period again, you can press M for meters. And there you go. FYI, if you need to make a subscript, that's Control comma in Google Docs. All right, so that's what I'm expecting. And then like here it says complete the practice problem. Okay, practice problem number 1. Well, over here we have practice problem and we have practice problem number 1. So you would complete this practice problem in the space or on a separate sheet of paper if you don't have space. Okay, the videos are pretty good. Some of them we'll watch in class, some of the shorter ones. Some of them may be longer, and if you want to watch those on your own, that would be advised. All right, but that's basically it. Like down here in a chart, all right, this is under angular momentum quantum number. So I'm going to come down and I'm going to find somewhere angular momentum quantum number. There's the chart. I literally just copied and pasted it into the Google Doc when I made this. And so the first one is N1, so I'm going to put N1 there. And I might need to delete a space so it doesn't mess up the formatting. But that's what we're looking for. Okay. The reading guide is meant to help you read and look for the important information. Some of it, like these charts, you can just look in the textbook and fill in the chart. But again, that's my way of kind of making sure that you've at least looked at the chart. So yeah, that's what you do. If you've got further questions, please don't hesitate to send me a message in Teams or send me an email. All right, have a nice day.